Today, we are going to study an extremely important stage in machine learning called model selection in machine learning. Model selection is not just about choosing an algorithm randomly. It is a scientific and systematic process of selecting the most suitable model that gives the best performance for a given problem and dataset. In this lecture, we will discuss what model selection means, why model selection is important, steps involved in selecting a model, important factors influencing model selection aspects, techniques used to select and compare models. Understanding this topic is crucial because even with good data, a poor model choice can lead to poor results. So the first one is Introduction to Model Selection in Machine Learning. Model selection is an essential phase in developing accurate and reliable machine learning models. In simple terms, model selection refers to the process of deciding which algorithm to use, what model architecture is suitable, which model performance best for a given dataset. Different models have different assumptions, different levels of complexities, and different learning capabilities. The main challenge in model selection is finding the right balance between model complexity and model generalization. For example, linear regression, decision trees, and artificial neural networks may all be applied to house price prediction. However, only one model may provide the best trade-off between accuracy and overfitting. Thus, model selection directly impact the success of a machine learning system. So the next step, what is model selection? Model selection is the process of choosing the best performing model from a set of candidate models for a specific task. This process involves training multiple models, evaluating their performance, comparing accuracy and error metrics, selecting the model that generalizes best to unseen data. The goal is not just to fit the training data, but to perform well on real world data. For example, a simple linear regression may underfit the data. A very complex model may overfit the data. The selected model should balance both underfitting and overfitting. Therefore, model selection focuses on performance, reliability, and generalizational ability. So the next one, importance of model selection. Model selection is important because no single model works better for all problems. Key reasons why model selection is crucial. Different datasets have different patterns. A model that performs well on one dataset may fail on other dataset. Poor model choice leads to overfitting or underfitting. Proper model selection ensures high accuracy, good generalization, computational efficiency, interpretability when required. For example, logistic regression may be better for small datasets. Random forest may work out better for nonlinear patterns. Decision trees may be preferred when explanation is required. Thus, selecting the right model directly affects system performance and usability. The next one, steps in model selection process, especially problem formulation. The first step in model selection is problem formulation. In this step, we clearly define what problem we are solving, what type of prediction is required. We must identify whether the task is related to classification type or regression type, and whether this particular problem belongs to supervised machine learning or unsupervised machine learning or reinforcement learning. And even this, whether this problem belongs to classification type of the problem or regression type of the problem. We also define what inputs we are having and what outputs we are expecting, what is the objective of our model aspect, and what is the success metrics. For example, spam detection, classification, house price prediction, regression, customer segmentation, clustering. Clear problem formulation ensures that we choose appropriate models later. The next one, steps in model selection process, candidate selection. Right? After defining the problem, the next step is candidate model selection. In this step, we choose a set of potential models. Candidate selection model stands for selecting the appropriate models that can solve the problem. These models can be simple models like linear regression or decision trees, complex models like artificial neural network or ensemble methods. And we have to consider model assumptions, model hyperparameters, model computational requirements. For example, for regression type of tasks, we can use simple linear regression, polynomial regression, random forest algorithms. For classification type of problems, we can use logistic regression, support vector machines, artificial neural networks. For clustering type of issues, we can use k-means clustering, hierarchical clustering. For selecting diverse models helps us compare different learning approaches. It facilitates for learning different learning approaches. The next one, steps in model selection process, performance evaluation. Once the models are selected, we evaluate their performance. Performance evaluation involves choosing appropriate metrics, measuring how well the model predicts. Common evaluation metrics includes accuracy, precision, recall, F1 score for classification. So common evaluation metrics include accuracy of the model, precision value of the model, recall value of the model, F1 scores for classification, mean square errors for regression, Shillhat score for classification, trained on training data, right? Each model must be trained on training data, must be evaluated for evaluation data, tested for with testing data. All these steps provide quantitative evidence to compare models objectively. So the next one you go into, right? Steps in model selection process, training and comparison. In this step, each model is trained using the same data set. We then evaluate each model, compare performance metrics, analyze interpretability and efficiency. Comparison is not based on only on accuracy, but also on training time, memory usage, deployment feasibility. All these things we need to consider. For example, two models may have similar accuracy, but one may be faster and simpler to deploy in real time. So we have to select a right model for deployment stage. The best model is selected after holistic and perfect comparison between the models. So the next one is steps in model selection process, hyperparameter tuning. Hyperparameters are parameters that are set before training. The examples include learning rate, tree depthness, number of layers. Hyperparameter tuning helps Find the best configuration for a model. Common techniques: grid search, random search approach, Bayesian optimization. Tuning improves model performance and stability, but requires repeated training and evaluation. So the next one, factors in model selection: problem complexity, data aspects. Model selection strongly depends on problem complexity of the aspects, data set size, the size of the data set, and feature relationships, and simple models work well. Generally, simple models work well and data is very small. Relationships are linear rather than non-linear relationships. When data it is in a linear relationships, it works well. Complex models are needed when data is large size, patterns are non-linear. When patterns are not in linear format, it is a little bit tough for assessment. For example, like linear models for small data sets, neural network for large data sets, random forest for noisy data. So we can use, linear models for small data sets, artificial neural network for large data sets, random forest algorithm for noisy data we can able to use over it, right? Next one, factors in model selection: interpretability and assumptions. Interpretability refers to how easily we can understand model decisions. Some models are highly interpretable, like decision trees, less interpretable, like neural networks. Model assumptions must also match data characteristics. For example, linear regressions assumes linearity relationships. Decision trees assume rule-based splits. In domains like healthcare and finance, interpretability is often treated as a most important aspect. The extent we understand the data is plays a crucial role. The next one, factors in model selection: scalability and generalization. Scalability and generalization are critical for real world aspects. Scalability refers to ability to handle large data sets, ability to make fast prediction. Generalization refers to performance on unseen data. Regularization techniques help to improve generalization. For example, logistic regression for real-time predictions, random forest algorithms for large-scale data, L2 regularization and L1 regularization for preventing overfitting data, right? A good model must scale well and generalize well. So the next one, factors in model selection: domain expertise and resources. Domain expertise plays a key role in model selection. Experts must understand data behavior, business constraints, real-time business constraints, practical requirements, and resource constraints include hardware availability and time limitations to perform or to complete that particular project, and deployment environment. Sometimes ensemble models are preferred for high accuracy, while simpler models are chosen for limited resources. Model selection techniques: train, test, split, and cross-validation. Train, test, split divides data into training and testing data sets. Cross-validation improves evaluation reliability by using multiple data splits, reducing evaluation bias. K-fold cross-validation is widely used for model comparison. These techniques ensure reliable performance estimation. Model selection techniques: grid search and random search. Grid search explores all possible hyperparameter combination. Random search explores random combinations efficiently. Grid search is suitable for small search spaces, while random search works better for large search spaces. Model selection techniques. Bayesian optimization. Bayesian optimization uses probabilistic models to guide hyperparameter tuning. It reduces number of evaluations, computational cost. This method is useful for complex and expensive models like deep neural network. Model selection techniques, model averaging and information criteria. So, model selection techniques, performance comparison and domain knowledge. The final model selection is based on performance comparison, multiple evaluation metrics, domain knowledge. Experts help choose the most suitable model for real world deployment. Thus, model selection is a blend of science, evaluation, and experience.